Okay, so notes for 5A from year 9, and you'll remember that when you have a number in front of a set of brackets, you expand, just being really careful that a negative times a positive is a negative, and a negative times a negative is a positive. Okay, so these are exactly as easy as they have always been. Times 1 just gets you the same thing back. And remember that x times x is x squared. Okay, I'm going to do C off to the side here because it's got a fraction in it, and that seems to annoy at times. Okay, so part of your life next year is going to be the fact that you have non-calculator exams. All right, so you have to know how to operate with fractions, and you haven't really done it without a calculator in a long time, so let's just talk about that. So in your brain or on a piece of paper, the thinking that you go through in this instance is that. Is that right? Is that what's in your brain? That's what needs to be in your brain. You don't have to write that down, but if it helps you to write it down, write it down. 7 goes in here 1 time, 7 goes in here 2. So this ends up being 4x over 1. And this ends up being across the top, across the bottom, 6 over 7. So that's the answer to C that we would expect you to get. All right? So writing things out if you need to is a good idea. If you do this straight in your calculator, you're going to get a wacky decimal, and we don't want you to have a decimal. So make sure that you either convert it back to a fraction. Don't round, no rounding off for 6/7. Okay, this one's fine. You just have to be super careful. So this is 2x squared minus x, and that negative sign belongs to that x. So when there's a minus right there, it belongs to that x. So it's negative x times 3 and negative x times negative x. This is a problem that I would say lots of students in year 10 and 11 miss. Okay, by the time you get to year 12, you're so used to doing them you don't miss it, but try your best to remember that that belongs there. Maybe in the old days, it's a possibility, and I really don't want you to do this, but I'm sure some teacher probably did it, where you went 2x squared minus x minus, and then you left the brackets there, and put 3x minus x squared, and then made that -1 kind of sneak through. That's a bad thing to do. Okay, it ends up getting confusing. So this is the best way, is to attach that to that and say it as you go along. Okay, here we go. Combine like terms. Everybody all right? Okay, that's your 8 and 9. Now, how about expanding a binomial? You ready for me to move? Okay, I'll wait for 1 second. So multiply the first 2 terms together, x times 2x. And then the outer term, so that term and that term. So the x gets multiplied by both of these. And then the -5 gets multiplied by both. And more often than not, so I'll say it one more time, this x gets multiplied by both of these, and that -5 gets multiplied by both of these. There's always going to be 4 terms to start, and then more often than not, the middles can be combined to simplify. Whoops. Is everybody okay? 1 minus 10 is -9. If you're bad at negative numbers, use your calculator, but you got to get good at them. You can't pass methods if you can't do negative numbers, so try to just tough it out. Okay, now there's one, you can square this by writing it down twice, because that's what squaring is, multiplying something by itself. So I can go x squared plus 7x plus 7x plus 49. First, outer, inner, last. And combining. Or I can know this special kind of formula which we derive by saying, okay, that's a plus b times a plus b. So it's a squared plus ab plus ab plus b squared, or a squared plus 2ab plus b. So that's what we got here. We got that squared, and oops, and that squared. And in the middle, we got these two multiplied together and then multiplied by 2. Okay, so if you feel like using that formula, that's good. If you don't, you don't. Okay, the difference of two perfect squares is this thing. That's not, I'm lying. These are exact opposites. Do you see it? So this one ends up being, am I going too fast? It ends up being x squared minus 6x, and then plus 6x minus 36. So when these are exact opposites, these signs, this just goes to 0, and I get x squared minus 36. So x squared is a perfect square, and 36 is 6 squared, so it's a perfect square, and so we call this the difference of two perfect squares. Okay, everybody's trying these by themselves. What did you just say? People. That's a 12. I'm going to do C in a minute. So I'm going to go x squared plus 4x plus 2x. A lot of people can see right now, oh my God, I can do that in my head. I'm sick of drawing all these little things. If you can do that in your head and put 6x here, totally fine. Now this minus sign has nothing to grab onto here, so I'm just going to leave it. But I got to put what I get in brackets so that I can take the negative through. Because that negative is of consequence. So I'm going to end up negative x squared. This gives me negative 7x, so it's going to be positive 7x. What's making it positive? That. And then minus 10. Okay, so I know. So those are gone, and these go to 13x, and these go to negative 2.